This question could be straight off a GCSE paper, and in fact it's quite an easy example of a GCSE vectors question. So to get from A to C, how do we get from A to C? Well, we have to do negative little a plus little c. Done. How do we get from O to P? Well, I probably want to go up here and then down there. So A to P, notice, is half of A to C. So this can be very helpful as a sort of line of working here. To get from O to P, write down what that root is. It's O to A and then half of A to C. Great, because since we know O to A and we know A to C, we can just substitute our expressions in for those. So O to A is little a, and A to C is our answer to part A. And then, does say simplifying our answers, you should always do that automatically anyway. Simplify that and we get that expression there, which you could factorise the half out of if you wanted to. Let's go on to part B of this question. Okay, so nothing to do with part 1. Great. Right, points P and Q have those coordinates. To try and make sense of a question like this, I really highly recommend a diagram. So I'm just going to draw those points and connect them with a line. There's P, and there's Q. I don't have to plot them accurately, I've just got roughly how they might fall on if you were to plot them. So Q sort of to the above and right of P. Okay, and then we've just got this description of where N is. It's a point on PQ, it's on that line, such that Pn to NQ is 1 to 2. In other words, N is a third of the way from P to Q. So I'm just draw it roughly there. I don't know what those distances are yet, so I'm just going to call them little x and 2 little x. Great, that's captured everything in this statement here, this line of work, this line of information. Find the coordinates of N. Well, I'm just going to come back to that statement I just made a moment ago, which is that N is a third of the way from P to Q. So let's think, how do we get from P to Q? Well, we start in the x coordinate, we're starting at 1 and we're ending up at 10, so we've added 9. If we're just doing a third of that, we must have just added 3. So 1 plus 3 is 4. So the x coordinate is going to be 4. And similarly, to get from minus 8 to minus 2, we've added 6, and a third of that is just to add 2. So minus 8 plus 2 would be minus 6. So that gives us 4 and minus 6 as our coordinates. And then the last part of this question, we have to find the magnitudes of those 3 vectors. Okay, O to P. Well, O to P is just the coordinates really, isn't it? 1 minus 8. How do we get from 0, 0 to 1 minus 8? Well, that's 1 in the x direction and 8 in the negative y direction. So square root of 1 squared plus 8 squared gives us root 65. If we do the same thing for O to N, using our result from here, square root of 4 squared plus 6 squared gives us root 52. And then finally P to N. Well, we haven't written down P to N yet, but we can very easily do that. How do we get from P to N? So 1 to 4 is plus 3, and minus 8 to minus 6 is plus 2, as we figured out before. There we are, 3, 2. And the magnitude of that, root of 3 squared plus 2 squared, which is root 13. Hence show that ONP is a right angle. Well, if ONP is a right angle, then triangle ONP is a right angled triangle and must therefore satisfy Pythagoras' theorem. If you look at our numbers that we've got, 13, 52, 65, you hopefully spot that that does immediately satisfy Pythagoras' theorem. We just need to write that down in a way that's communicable to the examiner. So root 52 squared plus root 13 squared equals root 65 squared. And then say what that means, don't just leave it hanging. Triangle ONPN satisfies Pythagoras, so ONP is a right angle.